I think in order to do page 29, the transformation of the tangent of x, it would be easier just to look at the tangent of x that we just drew, and understanding the same way that we've transformed graphs before, we know that we just take the graph of the tangent of x and we move it, shift everything to the right pi over 2 radians. Okay, so we can just look back here at the tangent of x. We're going to take the every significant part of the graph, and then really the only significant parts would be the x-intercepts and the asymptotes. Okay, so we're going to take this x-intercept, we're going to move it to the right pi over 2 radians, and so we can look here, we can go, okay, well, what used to be an x-intercept of 0 now is an x-intercept of pi over 2. What used to be, if you look at your other graph, an x-intercept of pi, that moves over pi over 2 to the right. And then what used to be a vertical asymptote at pi over 2 is now a vertical asymptote at pi. So the vertical asymptotes move over, pi over 2 radians to the right, so do the x-intercepts. So there used to be a vertical asymptote at 3 pi over 2, and now there's a vertical asymptote at 2 pi. There used to be a vertical asymptote at negative pi over 2, and now the vertical asymptote is the y-axis. Okay, and that means that we have, and we can use the pattern now. We know that this graph, tangent of x and tangent of x minus pi over 2, these repeat themselves every pi radians, and so once we get one period of this tangent function, we know that the rest of the graph will look exactly the same as just one of the periods of this function. Okay, and so we get vertical asymptotes every pi radians, and then x-intercepts every pi radians as well, and we know that the graph looks exactly the same. So I like the different colors of this one, sorry for the other one, using the same color. And there you go. Okay, so that's it. That's the graph of the tangent of x minus pi over 2. So let's go ahead and fill in the defining characteristics. The domain is all real numbers except for, so x, such that x is not equal to 0 plus, you can see that everywhere we have a vertical asymptote, the graph of this function is undefined, and so we just say x cannot equal multiples of pi, okay, where k is an integer. Told you I was going to keep making you write that. And then the range again is all real numbers, increasing, so on the interval from 0 to 2 pi, increasing from 0 to pi, and also from pi to 2 pi. You can see the y values are getting bigger on those intervals, not decreasing anywhere, no horizontal asymptotes, but we do have vertical asymptotes, again, multiples of k pi, or multiples of pi, so k times pi where k is an integer. Integers, remember, negative 3, negative 2, negative 1, 0, 1, 2, 3, and so forth. Okay? X-intercepts, we have pi over 2 plus k times pi, where k is an integer. The y-intercepts, well, in this case, in this particular function, we have no y-intercept. That's okay. We have no max, and we have no min. And again, we have a period of pi. This function repeats itself every pi radians. And again, this concludes our cosmic catalog, and we just concluded with page number 29, and I will see you in class.